Hello everyone.
Hello, sir.
Good evening, sir. How are you, sir?
So we will start from group 7. So all members of this group have you joined or not? Group 7
People are joining.
joining. Okay. Still you guys joining? Guys, we have 30 minutes for you. You already 5 minutes lost. We have only 25 minutes for you. So when you are going to start?
So, let's start. That means skill. Is my screen visible?
Yes.
Joy, I think you can start.
We can't hear you, Joy.
I hear you.
Good. Everyone can hear me? Can you hear me?
Yes, yes.
Yes,
Yes, Joy,
audible.
we can.
Okay. Hi, everyone. Apologies for that. Good evening and welcome to Group 7 presentation. My name is Joy Ukpabi and I will be starting our demonstration today. Now, before we go ahead, I want to just mention that our presentation would go in 5 phases, phase 1, 2, 3, 4, and 5. Now, these phases will take us through the technical aspect of our presentation, take us through the non-technical parts, and that's just how it is divided. All right. So now, imagine that you have a pet, a dog that you actually love and adore, and you just moved into a new town. Then you come in with your pet, and one day your pet swallows a bone, usually how pets do. You run helter-skelter, you begin to go through your phone. How do I get a vet service? And in the course of doing that, your pet stands the chances of dying. This is the exact problem that my client intends to solve. Now, my team, Group-7, was approached by our client, Sir Pravin Mishra, and intends to solve this problem that intends to create an application that anyone with a vet-related emergency can come in and then have their stuff taken care of, have their vets taken care of. So Mishra intends to solve this problem, and according to our clients, an application code has been established and built already by the developer. Now, this application code is allegedly works on the developer's laptop. Now, he wants us, Group-7, to take this application code and turn it into a production high availability application. Now, how do we do that? Now, we have to analyze the code base and understand the structure. But before I go into all that, I want you to meet 11 brilliant engineers whose expertise formed the success of this presentation. Now, before I go into introducing my team, I want to give accolades and a very big appreciation to Sir Pravin Mishra for all the support and all the learnings that we have acquired, and to our lead co-mentor, Sir Pravin Pandey, and to my very supportive co-mentor, Miss Anu, and myself, the team lead, Pratush, the co-lead, and every beautiful face that you can see on my screen. All of them, their ability, their collaboration made today possible. So hang in and watch with us. Thank you. Now, over to the next one. All right, so like I mentioned earlier, there is a problem established. We need an application for vet services. Now, this application, we have received a code base from my clients. My team, what we did was we analyzed the code base. We had to understand what kind of application we intend to deploy, and then find out the tools that we need and make several decisions. So in all of our analysis, we determined that we need to build an environment. We need to build 3 environments. The first one is a local environment. Now, the local environment will tell us whether the application code we have received actually worked. It is not enough for the developer to tell us that the application works. No, my team had to do an analysis, their own testing, to find out if the application code works. So first, we had to deploy locally using Docker Compose. So after our deployment, then we had to move on to the cloud and to the next. So looking at my screen, what we did was we had to automate every of our deployments, make sure that all our secret credentials are securely kept out of public view. We had to make sure that the entire platform is reproducible. As this presentation goes on, you realize why we made the decisions that we made. Please, next one. All right, so the entire project borders on taking a code base just from a single code base and making it an applications that can be delivered so that users can use it. Now, if you look at my screen, you'll find out that there are 8 services to be deployed, 2 environments, infrastructure as code, and CI/CD pipeline. What this means was that after our stand-up as a team, we analyzed the code base and realized that there are 8 microservices. Now, one would ask, what is a microservice? It is simple, not too much of English. Now, these are just independent small applications, too much of English. Now, these are just independent small applications merged together that when one service is down, the other continues to serve the public. So these microservices would be deployed across 2 environments, development and production. In development and production are almost identical. Only few changes were made. We considered cost, we considered time, we considered use. Now, the development is for my internal team. When something breaks in the prod, we go into the development, we fix it before we touch the prod. This is to make sure that there is 0 downtime while we are making these fixes. If you look at the business impact, Our major goal is to ensure that users do not experience any form of downtime during any of our changes. So that's one of the reasons that we have two environments. And then next one is infrastructure as code. Now, my team is made up of 11 engineers. Each of these engineers have access to all of these environments. Now, when the deployment team needs to deploy, I don't have to travel to India to meet Pratush to go use his laptop. No, we have our infrastructure defined as a code. I receive it, I deploy it. Everything is the same and the same across all environments. That is why our infrastructure is defined as a code. And then we have the CI/CD pipeline. Every serious DevOps engineer understands that for you to automate your work, we have moved beyond moving from one console to the other, from Azure to AWS. No, a CI/CD pipeline, 3 CI/CD pipeline have been provisioned to ensure that there is a continuous delivery. When any changes is made, it is highly automated. So in our key achievements, at the end of the day, you'll realize that we successfully deployed 11 containers on AWS ECR using Docker Compose. We did all of that both in dev, in prod, local. And then you also realize that we provisioned all our infrastructure using Terraform, which means that our infrastructure is reproducible anywhere. And then we implemented GitHub deployment. We also established a separate and prod environment. During our live demo, you will see how we're able to do this. Next one, please. Now, talking about the applications, recall that I mentioned that my team had to analyze the code base first. Before you begin to write your Terraform code, you write your Kubernetes manifest, you need to understand what you're working with. The application analysis told us that we have how many servers on the screen? We have about 8. The first one is the central config store. We have the API gateway, we have the visit service, we have the Gen AI, discovery service, customer service, vet, and admin server. Now, each of these servers are interconnected because they're all running in one application. So what binds them together is that the config server handles all of the settings. Every settings that binds the discovery server, the vet service, are all converged in the configuration server. And that is why when you're building the images, the config server will build up first. Then the API gateway is our entry point. This is just consider it a front door where you can walk into other applications. So this is the major connector between the outside world and our internal services. Then we have the visit service. These are the services that serve the public when they visit the domain. Then we have the discovery service. This is a very important service because it is in these discovery services that all communications disperse. When there's a request coming from the API gateway, discovery service takes it up and then finds out which of the services gets this request. So in this order, when we deploy, you find out that all of these services were able to be built successfully and without errors. Now, what are our challenges? We had, because there is no one here who confirmed that there were no challenges during their work. Now, complexities. First of all, we have always been working with monolith applications where we deploy a 2-tier, a 3-tier. But in this regard, we had a more complex stuff to do. That was why my team took about 2-3 days to understand the code base first, know what the complexities that we're about to meet, and find a workable strategy to use and deploy this. Then again, we had to maintain 2 environments. Maintaining 2 environments had to do with cost. You have to find out how much AWS charges you to keep your dev and prod. But all of these challenges, we're able to find solution because our fully automated cloud-native environment pipeline was very easy to use. You'll find that in demonstration. So next one. And then this is the most exciting part. As a DevOps engineer, you get to meet you get to use new technologies. So these are all the tech stack that my team used to deploy. Recall that I mentioned we had 3 environments, which means that there are certain stacks that we use in the local that we may not necessarily be using. Like one thing I need to mention is that when my team was deploying locally, we didn't do it from our laptop. We had to launch an EC2 instance. Now, this EC2 instance, we use Ansible to configure it, to make sure that all the dependencies, all the tools are installed in this EC2. The reason we wanted to use an EC2 machine was because the deployment team are scattered all over the world. Now, if I want to work on this local system, I need to have a control panel. This control panel is where everybody uses. So this is where EC2 comes in. We deployed locally from the EC2. And then we now have our infrastructure. Looking at the infrastructure, we had to build a VPC, a custom VPC, an EKS, an ECR, RDS. So all of this infrastructure, remember, we are packaged as a code. No one needs to go to AWS to loiter around. All of these things are codes and they're reproducible. Then we have the Kubernetes, which handles our pods. Then we have the CI/CD pipeline. So in deployments, you look at all my tech stacks here, Kubernetes, Helm chart, Argo CD, and then in observability, very important, because when anything changes, we have to know how it behaves at the back end. So the Prometheus and Grafana, the Zipkin, and our Alert Manager ensures that when anything happens, we pick it up on time, correct it in the dev, implement it in the production. Remember, our goal is that our client does not lose money, does not lose clients because of a downtime. Please, next one. And then this is the core principle. This was a very important area for my team to implement because everyone is guided by rules and regulations. So these are rules that guided everything that my team did. We call them the core principles. They are core because we held on to these rules. These rules guided us to deploy across all environments without errors. The first one is the cost awareness. We know how much it charges for us to be able to handle costs, handling two environments from prod to dev. So we need to make sure that my client is not overspending. We need to make sure that as DevOps engineer, my client is not wasting money. So we had to analyze the cost implications. Then the next one is infrastructure as code. I had said this before. If I take this infrastructure, give it to my teammate should be able to use it without error. So for that reason, nothing was hard-coded. Then next one, no secret credentials are ever committed to GitHub. We're very, very specific about this one. All our secret stays of GitHub. Next, there is only one single source of truth for every deployment, and Git becomes that single source of truth. If you go to our Git, you'll find out all our histories, our errors, our failures, our success, our commit history, who committed this, who did that. The Git becomes the reference point for every member of Group 7. Then the next one is all our environments are structurally identical. What this means is that the development environment mirrors the prod environment. Whatever happens in dev happens in prod. There are only minor differences. You won't even be able to notice it, as we are going to show you during our demo. Then security. Now, in the world of hacking, everybody knows that if you leave your infrastructure, your environment porous, there is a next hacker waiting to exploit it. That is why we made sure that we handled security from the very start till the end. And then we have our observability stack. Whatever happens needs to be traced. We need to check the log. When something breaks, we need to check to the log and find what got broken, when it got broken, and fix it. And even beyond that, we get an alert. All of these things have been set up so that my team will be in total control. Remember, our goal is to make sure that our client is happy, client does not lose money, and our users are not left stranded. And then finally, and very importantly, naming tag. Now, the naming tag becomes very, very important. I won't be stressing on this part, but when we get to the deployment, but when we get to our demo, you'll see how the naming tag changes across all environments. So that's it for all of our principles. Next. And then, okay, now I spoke about costs. This is business. Money is important, and my team truly understood that. That is the reason we had to take our time to break down the cost. What would it take for us to run an EKS across two environments, an EC2 and RDS? We had to make sure that we did a breakdown Even though my team is privy to use a free tier account, but that does not mean that the resources that we have to waste it. So it is important as DevOps engineers for us to know the cost implications. So we did a cost submission for the dev environment, as you can see in my screen. We did it for the prod and other extra expenses like buying a domain name and the loading credit for our API credit. We knew how much we were about to spend. For EKS, about $72 per month. For EC2, we have about $30. For EC3, for ECR rather, we have about 20 cents. Now, this tells us when to bring down our server and continue the next day and that's why when we use Terraform, it was a smart idea. We know when to destroy an infrastructure and bring it up. That was why this cost analysis became a very integral aspect of our project execution. Next. So this is still the prod environment and the cost analysis. So that is it. This is the end of phase 1 for my team. The next one you're going to be seeing is a CI/CD workflow, which will carry a testing phase and a demonstration part. So please sit down with us and enjoy. Over to you, Pratish.
All right. Thank you, Joy, for such amazing, beautiful presentation. Now I will explain about the CI/CD, which is the core component of our project. My name is Pratyush Pahari. I am one of the core team leads of Group-7. So CI/CD. Previously, before the CI/CD came, every time the application code changes, someone has to manually build the Docker image, tag it, push it to the ECR, and update the values and run Helm upgrade. Everything is manual, and we all know manual pipelines do not scale. That's why we have introduced CI/CD, two concerns, two different responsibilities, and two separate tools. So CI answers one question, that is the code good enough to deploy? The responsibilities are pretty clear. Build the artifact, run the tests, scan for vulnerabilities, and push it to the registry. Also, if any time any of the step fails, it will immediately stop the pipeline and do not let the broken code to move forward. And regarding the continuous delivery, it only answers what should be running inside the clusters. The responsibilities for the continuous delivery is also pretty clear. It watches Git as a source of truth for any of the changes that is happening across the environment. It compares the desired state versus the current state. And if they differ, it will sync the cluster. And if something fails, it will roll back. Now, you might ask why to keep this both CI and CD separate? Because they change for different reasons. If any day, if you want to use a different CI tool, instead of GitHub Actions, you might use Jenkins. The deployment logic doesn't care about it. If you change the CD tool from Argo CD to Flux CD, the build pipeline doesn't care it. So CI basically decides what is ready to deploy, and CD decides what should be running inside the cluster. Now I will hand over to NT to discuss about the monitoring and observability stack, which we used in our project. NT?
Hi,
Are you there?
Auntie. One sec. So if NT is not here, you can move on with CI/CD and then we'll get back to her.
All right, then I can start my demo with the CI/CD along with the chaos testing. Let me share my screen.
Okay.
Guys, you have 10 minutes only, okay?
Okay. Do you have your screen?
please let me know if all the screens are visible properly.
Absolutely. Yeah, yeah.
Oh, good. And at first, I'll show you. Okay, put it down. Okay, this is our actual application. Are you able to see the application?
Yes, yes.
Yes, visible. Working
Yes.
good.
Yeah,
Okay.
sure.
Okay. So this is the application. We can go ahead. You all can go ahead to petclinic.prati.dev. You can register yourself as owner. Like I can do it. Anything and give a number. You can submit it. It's working fine. And you can also add a new page, any of the name. You can give name. You can give the birth date and submit it. And you can also add a visit to a doctor with a description of their illness, and it will be visible there. And there are also veterinarians number whoever is there. That will be present here. And this is the dev environment, and all this is the Jenkins server, where with Jenkins it's tracing the whole thing. And this is the admin for dev environment, admin for prod environment. And this is the Argo CD UI, where you can see every service is properly healthy and sync. Right. Let's quickly jump into our CI/CD demo. At first, in a terminal, I will run to check. We'll do one change in the veterinary service demos README file, and we'll then check the whole CI/CD pipeline to get run. Before that, let's check the tags initial. What is there? Okay, you can see the initial tags are version 1.0.0, and also in the Kubernetes cluster, also the tags are version 1.0.0. Now we will run the CI/CD pipeline. Let's run the CI pipeline. Okay, now we'll go to the actions, and the CI pipeline started running. Ignore this one. This one is the default source code, which is pipeline, which is there. This one is the pipeline which I have wrote. And you can see we have used path-based filtering, and that's why we only changed. You can see on the terminal, we have only changed the README file of vet service. So that's why the veterinary service only got triggered. So these are all the phases of the CI pipeline. At first, it will set up the job, and it will set up the environment, install JDK and all, and it will use Docker buildx and QEMU for the ARM64 cross compilation, because the nodes in the AKS cluster only uses the ARM64, but by default, GitHub Runner uses x64. So we have to convert it using the cross compilation, and it will take a little bit of time, 2 to 3 minutes, and the tree scan is also happening. So the tree scan, it will push the image to the ECR, and after that, it will trigger by a repository dispatch event to the infrared. We'll check, it will trigger soon. In the meantime, I can show you this Grafana, where everything is up. This is the Grafana for Prati.dev. You can go ahead and this is you can see all the services are properly up. Everything is fine, working fine. And this is the Jenkins to trace any of the service. If I give service name, any of the service.
I have a question, okay?
Yes, sir.
I have a dog His name is Anna. Okay.
Okay.
I want to register with your website, take appointment for
Hmm.
my dog.
Hmm.
So how I can?
Okay. So for that, you need to contact with the source code owner, because our scope is to deploy the application which was given to you, not to do anything with the source code. So we have not done anything. We cannot do anything with that. So you need to contact with the SDs for that, software development engineers, to
Pratish is
manipulate
asking
with the
how
code.
will he
No.
register? He's asking how will he register? That's what you're asking, sir, right? How will
Exactly.
you register?
Yes.
Yeah. So just go and register. Yeah.
The
If
test. Yes, please.
Yeah.
Okay, if you want to register yourself, uh, you can just at first give your details. You will can submit it. After submitting, it will be visible in the find owner section.
Deploying, so
Okay, maybe it's taking time. Okay, it's visible here, and you can add your pet at the first.
Sorry, I don't see my name. Can you please enter my name?
Yeah, please. Okay.
Yes, this is here. You can add a new pet, maybe whatever. What name you want to give, sir?
Anna, Anna.
Anna. Birth date, anything I can give?
Yes, anything.
Okay. It's a cat.
Dog.
No. And you can submit it. Now you can also add a visit anytime you want to visit. What time you want to choose?
Tomorrow.
Okay. Description of the illness.
Anything you
Maybe
can mention. Yeah.
fever. Maybe. Okay. And I have added the visit.
Okay. I mean, there is no kind of thing like no
You can
restriction. I
select
mean,
as
I will definitely get an appointment, right?
Yeah, sure.
yes.
Okay. And can we do same thing on chat also?
No, our chat is currently not working because we haven't used the OpenAI API key right now. So
Okay. Because earlier I have seen other group they have done same thing with chat also.
okay. Yeah. I'll do that during the final demo day. We have bought the
Okay.
OpenAI.
Okay. I have done. You have anything you can explain within 2-3 minutes? After that, we will
Okay.
take another group. Yes.
Okay. And this is the whole CI/CD pipeline. I think this is the pipeline's CI got triggered. After that, it notified the platform using the dispatch event, and it actually changes the image tag. If you go to the code, in the code section, if you go to the commit section, you can see this commit is done by GitHub Actions. And if you go ahead, you can check the image tag got changed. Yes, the image tag got changed here from version 1.0.0 to this. All right. Now we'll pull all the changes from Git, and we'll also sync it with the Argo CD, because by default, Argo CD takes 3 minutes time to pull all the changes. Every time it takes 3 minutes. Okay, it's wrong. copy it properly. So we are pulling the changes and we are doing hard refresh to the Argo CD so that we will not waste the 3 minutes of time, which is by default for Argo CD, and it will pull the changes of the tag.
You can show that email and all that, right? That you can get it.
Yes.
Yeah.
That
Yeah,
is a
lots.
different demo. That's a
Yes.
chaos testing demo. So if time permits, I'll do this. Else I keep it for today. Okay. And if you check in the dev Argo CD, everything is properly health and synced. If you check the veterinary service, it's because the dev environment is using the auto sync, so it's automatically synced. Now, if I use the same thing, if I pull the image from the dev ECR and push it to the prod ECR, and after that, sorry, we are actually copying because the image is already built and pushed to the dev ECR. So we are copying it from the dev ECR without rebuilding it and pushing it again to the prod ECR. After that, we'll check the Argo CD will be out of sync, and we have to manually sync it by going to the website of the Argo CD. Nande sir, I will request you to allow us 5 minutes more so that I can complete this particular dev.
Okay.
Thank you.
All right, I have already taken it from the database here and pushed it to the. Now I will again do the same because Argo CD takes time. So this time I will do the hard refresh so that the tag will be changed and Argo CD can get idea of the change tag. Cool. Now if I go to the website, if I go to the particular head service, you can see this is out of sync. So this time this is not gotten manually auto synced. We have to this is not gotten auto synced. We have to manually sync it. Click on synchronize. Yeah, it's synced. Now it will take a little bit time to process the whole thing, and it will show it healthy. I mean, we can see the whole thing in a different terminal. If we run it, and yeah, what will get initialized soon. After that, we can do a smoke test also to check the whole thing. Yeah, what started running. It's initializing. So now we are able to see it as healthy. And if you go to our website also, yeah, see, it finally came back. Working properly. And let's see. Yes, you can see Argo CD that this is the prod environment and it's finally got healthy and synced. Perfect. And you can check the terminal also. Yes. As we all know, after the new pod course generated, Argo CD will actually terminate the old pod. And that's how we'll face zero downtime whenever we need to make any changes to any of the services. All right, that's all from my side.
Okay. Do we still have any time for any of our teammates to continue?
Okay, thank you so much for a wonderful session. One
Okay.
of the best you have presented. Okay,
Thank you,
Thank
sir.
you, sir.
there is no any chance, anything I can comment on that, like you should do thing. Okay. Just I would say just take care of your time, right? Only
Yeah.
one concern I have. Just take care of
Mm.
your time. And one more thing, you have only two person, only Joy and Pratyush explain all these things. So if you talk about Group-7, so I personally know only two person. You have explained very well. What about others?
Actually,
Others
we
are
have.
here. Okay, go on.
Yeah, please go ahead. Go ahead.
No, I
Okay.
mean to say you took almost 10 minutes, 8 minutes. So at least you should give some time, 1 minute, 2 minutes to other person also to say something.
Mm.
One line, two line, three lines.
No,
Like
to be
I have
honest,
done
to be
this, I
honest,
have contributed this kind of
to be
thing. At
honest,
least, yes,
to be honest, we need to work on this time management issue thing. I
Time.
mean, Anuradha ma'am also said to us, actually, for example, Joy is taking a little bit of time, and my demo is going on further because I initially I planned to do two demos, one for the CI/CD and another for the chaos testing. But maybe I need to work on the time management thing so that we can
actually,
Mm.
everyone can contribute.
it's a team presentation, right?
Hmm, hmm, hmm.
So I believe at
Yeah.
least few
So
people you
other
should.
teams, so
Yeah.
other teams are also
We still
there. And
have other
we,
people that
yeah,
want to present.
yeah. But
Yes, all our teams are ready. There's time. We have everyone ready and they have a part to play.
Yeah.
every team is
If we get
present.
extra 10 minutes,
Yeah, every team is involved. Only thing because of time, we are still working on that so that we can crunch the whole thing and then somehow other team members also are there because in the afternoon we went through one dry run that time everybody was involved, but there again we found time was a constraint for us. So the team is trying to crunch the whole thing for the presentation and other things. Otherwise, if you see a presentation, every team member comes later on, but demo was important. So that's why we gave the introduction and the demo.
Your team took almost 35 minutes, right? Other team
Yeah.
also took 35 minutes. But
Okay.
difference is that you have only two person and they have many person they have explained all these things.
Hmm. Okay.
okay, noted, sir.
So I can say like yes, I write that name also like this person, this person, this person. The person explained like I have done Terraform. Someone said I have worked on CI/CD pipeline. So I know okay, this person contributed something. In your demo, I can say only Joy and Pratyush done very well. Excellent job. What about others? I don't know about others, what they have done. Whenever I see recorded video, I will see two faces only. Only you and Pratyush, Joy and Pratyush. After a few months, if you team members will go and see recorded video, so they will say, oh, only Joy and Pratyush, what I have done there. Are you getting me what I am saying?
Yes, I
Noted,
understand.
sir. Yes.
We have noted the thing. We'll absolutely work
I
on
am
it.
not
And
saying I am not saying to give all the time to, but at least 1 minute, 2 minutes, you can give them like yes, please briefly explain what your contribution is there.
Okay,
Yes,
sir,
Bhupender,
noted.
Bhupender, you have question, then please ask your question.
No, I just want to share I just want to give the compliments like Joy, you did the great job. Actually, that was very amazing how you are describing the things and the storytelling was very good. So that was
Yeah.
very amazing. We have to
Yes.
adopt
Mhm.
this thing. So yeah, that
Yeah,
was
very
very good.
impressive. Very
Yeah,
impressive.
very
Thank
I mean,
impressive, very
the way
impressive.
the started Joy, very expressive.
You
Thank you,
deserve to
sir.
be a good speaker. In AWS also, we are having some training for this speaking, and you are doing great thing. Seriously,
Yes, yes,
it's very
exactly.
amazing. So
Oh,
that's why, because
during our practice also, I was telling her she has a natural capability to like the present the whole thing very beautiful.
Yeah.
That's really impressive, to be
Thank you.
honest.
Thank you.
But
Appreciate
but
it.
but give some time to others also, right?
Yeah,
If
yeah.
it's a
I assure
teamwork.
you,
Yes, noted.
you will not get disappointed on Sunday.
Okay.
From my side,
Certainly.
I'll assure you.
Okay, then thank you so much. Thank you. You have
Thank
wonderful
you.
job.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you for your time.
I mean, 9.9 out of 10, you can say.
Thank you, sir.
Wow.
There
Thank
is always scope to improvement. Okay. That's why I said
Thank
9.9 out of 10.
Thank you.
Noted, sir.
All
Thank
right.
you.
Okay.
Thank
Okay,
you.
guys. Thank you so much. We are moving ahead
Thank you, sir.
for group number 10. So who is there from group 10?
We are here, sir.
We are here, sir. Matlab, raise your hand. I mean, there are so many faces I don't see. Who said I am here? Okay, Vivian. Yes, Vivian, you can start. Your team, all members have joined or not?
Yes, most of us have joined, sir.
So are you ready to present?
Yes, we are ready, sir.
Okay, please go ahead. Thank you.
and ask everybody to switch on the cam for the team. Rest team can switch off their camera. Okay.
Yes, thank you so much. Please turn on your camera who is in team. Thank you.
Okay, I just want to confirm that my screen can be seen.
Yes, we can see.
Okay, standing on the already existing protocol, my name is Vivian Chiamaka Okose, and we are presenting for Group 10, and our theme of the project is Pet Care Clinic Cloud Ops. I want to say thank you to Prof. Mishra, who is the convener of this program, and also to our co-mentor, Pravin Pandey and Vincent Igwoko. Thank you all. And meet the engineering team. I co-led this project with Afoma Igwogu. I also partnered with Nikki as a cloud and infra engineer. There is Hashim and Florence. There's Temitope, Belumi, Nitika, Ugochukwu, Chime, and Mohana. We all had our individual contributions in this project. As a project lead and cloud engineer, I partnered with Afoma. We led all the sprints and the stand-up milestones tracking. We supported CI/CD pipeline for Afoma. She actually supported the CI/CD pipeline design alongside Nitika and Ugochukwu. Then I worked with Nikki closely to manage multi-environment setups, configured config and cluster across the team. Hashim and Florence, they co-owned the Docker file creation with and pushed images to the ECR and verified registry workflow. They both integrated Docker images built into the CI pipeline. Temitope and Elumi, they set the resource request and limits for each container. They created the base Helm chart structure for the project. They contributed to the Helm chart values for environments. Nitika, Afoma, and Gochukwu were our CI/CD engineers, and they set up the Docker build and ECI push in the pipeline. They also created branch protection rules on the main branch, and they also built the CD stages with Helm deploy. Chime and Mohana were our monitoring engineers, and they ensured that the monitoring infrastructure were production ready with high availability in mind, and also designed and built service level Grafana dashboard to provide real-time visibility into the application health and infrastructure performance. For our projects, we ran 8 independent microservices. We had the API gateway, which ran on port 8080. Our customer service ran on port 8081. Vet service ran on port 8083. Our visit service ran on port 8082. Our config server ran on port 8888. Our discovery server ran on port 8761. Admin server ran on port 9090. And our Gen service AI ran on Gen AI service ran on port 8084. I'll give the floor to Nikki Nkiru Obilo to explain the system architecture for us. Nikki, please take over.
Hi, good evening all. I am Nikki, the Cloud and Architecture and Infrastructure Engineer with our team lead Vivian as a partner. So my role involved setting up the infrastructure for the pet care application. So the architectural diagram walkthrough you see here is the full setup for our pet care app from top to bottom. Everything starts with a push to GitHub's main branch, which triggers our pipeline. So for CI, we used GitHub Action, and for CD, the continuous deployment, we used Argo CD. When a client tries to access our app from the internet, the traffic first hits our ALB, the application load balancer, which further directs the traffic to our API gateway. The API gateway now directs the traffic to the particular service the client is trying to access. For monitoring, we used Prometheus, and this is displayed on Grafana using the UI based of Grafana. The Zipkin service traces all the traffic within the application. We used Azure OpenAI to set up the API key for our Gen AI service for the chatbot, which you'll be seeing during the demo. And each of these services had its own database, which you see as the Amazon RDS MySQL. Thank you.
Thank you, Nikki. So our tech stack comprises of Spring Boot version 3 for our application. Our container ran on Docker version 24. Our orchestration, which was Kubernetes, ran on version 1.29. We use GitHub Actions for our CI/CD pipelines. We use Terraform, EKS, ECR, VPC plus IAM for our cloud and infrastructure as a code. Monitoring and observability were used. The tools we used were Prometheus, Grafana, and Zipkins. Security was GitHub Secrets, branch protection, and we also beefed up our security vulnerabilities testing using Trivy test and checkoff test. Our source control was GitHub, Gitflow branching, PR reviews, and our upstream sync with the main Spring Boot application. How we worked, I and our former made sure we had our daily stand-up meeting using Jira as our tracking tool. We made sure that no direct pushes ever went to the main branch ever. And we ran this sprint for 2 weeks with clear goals and trackable tasks. We had our daily stand-up meeting for 8:30 p.m. Nigerian time. And our quality standards were before any PR was made, before any merge was made, there must be at least one person to review and approve. There were no hard secrets coded ever. So Nitika would take us around the CI/CD pipeline explanation. Nitika, please take over. Nitika, are you here?
CI/CD. Yes, I'm here. Am I audible? Hello.
Yes, you are. Yes, you are. Please continue.
You are audible, Nitika.
Hello, I'm Nitika from CI/CD engineer team. I have worked alongside with Afoma and Ugo in this project. We created multiple automated pipelines. The CI pipeline run test and validate pull requests. The CD pipeline build Docker images. It pushes them to Amazon ECR and deploys it to Kubernetes. We separate deployment pipelines uh, were configured for development, staging, and production environments. We also created a rollback pipeline using Helm rollback to quickly recover from failed deployments.
Okay, Nitika, thank you
This
very
is the
much.
CI.
Nitika, thank you very much. I'll hand over to the Kubernetes engineer, Temitope, to take us round the Kubernetes team and what they did.
Hello everyone, I'm Temitope. I'm one of the Kubernetes engineer. I work along with Pelubi. So our main job was to take all the containerized microservices and make them run efficiently on AWS EKS. Without touching any application code at all. So the art of my contribution was actually building a professional M charts, and this presents chart orchestrates, which actually orchestrates all the 11 services as dependencies. So the entire application can be deployed, upgraded, and also rolled back. They can actually roll back together using a single M command. So we created 11 clean, consistent subcharts, one for each microservices containing deployment, service, and ingress. Although one of the biggest technical challenge was ensuring the correct startup sequence. All microservices actually depend on the config server and discovering server. So if the config server and discovery server is not starting early, and so every other services that started before then will actually crash. So we solved this using the Kubernetes in its container combined with reusable M template EPAs. So config server start first, and discovery server actually wait for it, and every other services wait for both. All defined ones in epa.tpl, and they can actually be reused across the chart. So also we implemented the solid production practices, including the readiness and liveness probes, and also the engines ingress that expose only the API gateway to external traffic. So this is how we're able to manage the Kubernetes, and all the services will actually run it perfectly. Thank you.
Thank you very much, Temitope. For monitoring and observability, we use Prometheus as a metrics collection engine to scrape data from all our 8 services every 15 seconds. And Grafana was our dashboard visualization tool, which turned Prometheus into the metrics into readable real-time charts. For our security control, security is not a feature we added at the end. It was built in every layer. And we had zero trust posture. So every service was authenticated, every credential was vaulted, and every change was reviewed, and every connection was encrypted. The challenges and lessons we learned, we always set realistic probe delays for Java-based application, and we made sure that we increased our ports so that they don't run out of memory. For future improvements, we suggest that these are what we suggest for future improvements to the originators of the source code. I want to also say thank you once again to Praveen Mishra, our program convener, Praveen Pandey, and Vincent Egu. So I'll hand over to Afoma to take us down the demonstration lane. Thank you, everyone. Afoma, are you here? Can you please take
Yeah,
us
I'm
down
here.
the
I'm
demo?
here. I'm trying to share my screen. Hello, everyone. My name is Afoma. Today, I'm going to walk you through what we've done. A team of 11 engineers, and we built a very amazing production in 2 weeks. Okay, so it is a production grade microservice application running on AWS EKS. All right, and it also has a fully automated GitOps pipeline using GitHub Action for the CI and also Argo CD for the CD. It also has a complete monitoring stack with Prometheus, Grafana, and Zipkin. I will start by showing you the project structure, then I'll make a live code change, push it, and you will watch the entire pipeline run. I'll also show you the app and the monitoring dashboard. So let's get to work. Okay, right now you can see this is our work. This is our repo, pet care clinic, cloud ops. All right, now we have our CI pipeline. Our CI pipeline, anytime I make a push, it compiles the Java code and runs the tests. You can see our pipeline, what it looks like. Let me scroll up so you can see our pipeline. So this is our pipeline. All right, so now let's check our CD pipeline too. So this is our CD pipeline. For the CD pipeline, this triggers on pushes, all right? And it does three main things for us, okay? It builds Docker images and pushes them to Amazon ECR. It updates the Helm value file with the new image tag. And then it tells Argo CD to sync the new version to our Kubernetes cluster. All right, so let's do something. So the first thing I'm going to do is I want to make a little push, and then we'll see. I'm going to do something on the README. So let me come to the README. Already I've pulled from the main. You can see I've already done a pull. Now let me just do something. So I want to add, like line 64 says, this is not a demo environment. Every pipeline. So I want to add end every configuration. Let me just add this. Okay, then I control save it. So I want to do, let me git add what I did, git add readme.md. So git commits updated the readme. Okay, so this is what we did. I updated the readme, updated readme. Okay, all right, so I'm going to git push origin dev. Okay, so now I go to our GitHub. All right, so these are GitHub. I have a pull request, so so let me create and compare pull requests. So you know why all of these security measures have been put in place so that people don't just push things the way they like. Okay, so I updated the README. So we arrange it in such a way that when I create these pull requests, I'll have to get a reviewer who will do the work for me. So I'm requesting Vivian the process to do this work for me. So Vivian, review this for me so I can continue my work. Vivian, are you here?
Yes, I'm working on reviewing the work already.
All right, thank you.
Can you show me the website URL application where it is running? and their functionality.
Sorry, sir, what is that? To show you?
Yes.
Okay, this is it.
Yes,
Okay,
so how it is
so
how it is working, what we can do here.
okay. All right, so now you can see here, you can register, you can edit and add, like for here, if I click on this person, I can also add a new pet for him. Then I can also register an owner. Let me register an owner. Sony 22. Let me just write 22. Address Lagos. City Lagos. So let me put the number. Yeah, so I've registered him. Let me scroll down and show you who I registered. So you can see this is 22. I just registered him. Okay, so I can also add a new pet for him. So 22 has a pet called Trail. The pet was born on the 2nd, and the pet is a bird. Yeah, so yeah. Okay, so this is what it looks like.
Can we do same thing on chat also, with help of chat also?
Yes. Okay, register. Register Peter Fish as a pet owner, and also register his pets, and also register his pets.
The first hand, I think you missed it. You just survey and so register pet fish, and you missed D.
And also
No, not there. No, not there. Go back a bit.
Register
Yes,
Peter Fish.
yes.
Okay.
And
also a pet. Okay, a pet owner, Mr. Fish, a pet owner. No, a pet owner. And
I am end user, so how I can know like what is the sequence to put here in chat?
Sorry, sir, I didn't get what it says. Sorry.
I am an end user. I want to register myself with help of this chat. Though, how can I do?
So that's what I'm trying to do. I'm telling it what to do. Like an end user, I just come here and tell you that you want to register, and then it asks you some things, and then it registers for you. So that's what I'm trying to do. So
why not you start the conversation normally? Hello, the system will ask you what do you really want. You now continue the conversation. I want to register a user.
Exactly.
You know, let's take it through that way and see if it works.
Yes, exactly. You just put I want to register something like that. You know your prompt well, right?
Yeah. So it tells me what to do. So the name, first name, Peter Fish.
Yeah, this is the right way.
Address, Ghana. City, Ghana. City, Let's write this something down. Telephone number. I'll put a 10 digits number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Hello, Former, is very likely you have finished the token. You know
Yes,
that is
yes,
set up
exactly.
in the this. So
The
that
token
is
has
why is
finished.
yeah. So
We have finished the token actually.
yeah. So what you need to do next time, we'll have to increase the token value so that it will enable longer
It's
conversation.
okay, no problem at all. It's okay. It's working. I can see, no problem.
Okay, all right. So these are the things. So I go back to what I was doing. So this is the action. Everything has built already. So I'll just go and show us the next thing. The next thing I will show is the monitoring. I was supposed to show you how all of these things worked, the build, the push, and the job, and all of that. But let me just go straight to the monitoring. So for the monitoring, we are starting from the Prometheus. So the Prometheus actually, this one is a metric collection engine. So what it does is that it creates information and which Grafana actually reads from. Okay, so I'll just go here. I already have it running. You can see it's already running. I've already post forwarded it. So just go here and see what our Prometheus looks like. Meanwhile, this is the Argo CD. So while I was working, this is the Argo CD when I pushed it. So this is what it looks like. Let me go back a bit. So let me open it. So these are Argo CD. Everything is synced and everything is green, showing healthy. You can see the hair, everything is green. So once it's green, it shows that it's healthy and you can see the tree, how everything works from. So you can see from the API gateway, all the connections, how everything moved from Grafana provisioning, Prometheus config, admin server, and it moved down to the end. Okay, so you can see the tree, how everything works. The API gateway, how it's entered and all of that. The config server, everything, and everything is working perfectly well. So now let's go to the Prometheus. So for Prometheus, let's check our status and see how that goes. Now let's go to our targets. You can see everything is up and healthy. It also shows green. If it shows red, it simply means it's unhealthy. If it shows yellow, it simply means it's unknown, but ours shows green everywhere. So these are Prometheus. Everything is green, showing that the whole thing has worked very well. So it's monitoring everything. Okay, now let's check our Grafana. So for the Grafana, this one is also a metrics visualization. Okay, this is a metric visualization a tool. Let me reload it. It's a metrics visualization tool. You can see the whole thing. Okay, so now we're going to create something. Let me just go quickly and create something. So please, everybody in my group, try to create something so you can populate the owner, the text created, and all of that. So let me quickly create something again. When I refresh, the things I created before left, so it's new now, like I pushed, so it's a new push. So I have to do all of those again for them to appear. So let me register an owner.
You have already explained all these things, right?
Yeah, if I register it, once I roll it, everything will come up there. It's pinned up.
Okay, it's okay. We don't have much time actually, right?
Okay.
We have
All right,
another
so
group,
this is
we have another group session after this. So
okay. So
let's stop here. Okay, and thank you so much. You have done very good job. Excellent overall. And there are a few things we need to improve. For example, I think you have only 4 or 5 people involved in whole session, right? I can
Yeah,
see only
because of time.
Vivian, Nikki, Nitika, and Femikina. Only 4, 5 from you also.
Yeah.
What about others?
Yeah, the
The others are
Present.
here.
Travis, if you
Present.
check through the repo, the GitHub repo, you will also see the collaboration there. The team members actually contributed. You know, they were in sub teams, and each
No,
sub team had their
it's
work to
okay.
do.
They have worked on backend, but we are we are on live, right? We have all these things. I mean, we can see 4, 5 faces, and we are also recording your session whenever you go and see this recorded video. So we can see only 4, 5 people, right, who have done actual work on backend. We cannot see their faces on this recorded video. So at least we should give some time, like 1 minute, 2 minutes, 3 minutes. At least we can see 2 minutes. We can give them to speak something about their contribution, what they have done, right? I mean,
Okay.
it's a 30-minute session,
Uh,
so we can give 1 or 2 minutes to speak them same, right?
all right, sir. We'll do that.
Yeah, rest of all you have explained very well. All things are very good. I mean, there is no issue at all.
All right. Thank you so much, sir.
Okay, thank you so much. Thank you. Thank you. Okay, bye bye from my side. And who is there from group 2? Tanisa, I think, right? Tanisa team.
Yes, sir.
So your team is ready?
Yes,
Yes, sir.
they're ready.
All members have joined or not?
No, not all are available, but few are available. We will take it, sir. Due to some time zone confusion, few people
So,
not joined, but remaining all are available. Gundal is
Yes.
from the team lead. He will start from our side.
so how many members are not available right now?
I think 4 or 5.
4 and 5.
Yeah.
Okay. Okay. I strongly believe they should be joining on Sunday, right?
Yeah, probably
Yes,
they
sir.
will join. I
Okay.
believe.
Please convey my message. If they will not join on Sunday, they will not get certificate.
Yeah,
I'm
definitely, sir.
100% sure. Kuntal, if you are available here, somehow, anyhow, you will not be available. You cannot join on Sunday. No problem. I will give you certificate because you are available today.
Yeah.
But there are 5 members, they have not joined today. If they will not join on Sunday, they will not get certificate of this TMI. So please convey this message to them.
Yeah.
Okay, Sunday
Okay,
is
sir.
very important. Yes. Yes, we can
Yes, sir.
proceed. Yeah, we can proceed, Kuntal. Thank you so much.
Kuntal will be presenting
Yeah.
the PPT, and then Varun will show the demo.
Where is my screen? No. Okay, just a second.
Yeah, it's good. You can make it in a presentation, but
Yes, it is visible.
Yeah. So, good evening. Good evening, everyone. My name is Kuntal Darwadkar. I'm the team lead of Group 2. And the project we have worked on is Spring Pet like microservices project. And for this project, the technology which we used is nothing but AWS EKS. We also used Kubernetes, Terraform. Post that we used GitHub Actions. We have used Spring Boot. We have also used Prometheus Grafana as well as the Zipkin. When it comes to role, we had actually divided the role into nine different sections. The very first section was nothing but of the Scrum Master team lead. For the Scrum Master, I had actually taken up the responsibility to work as a Scrum Master. Apart from me, I was also joined by Swarbo Gajali to take up the role of Scrum Master. When it comes to AWS infrastructure, Chioma worked on building the AWS infrastructure. For the CI/CD engineer, Theodora took the role of CI/CD engineer for configuration
Sorry to
and for the
disturb you,
discovery.
Kuntal. You are too fast actually. So please go slowly a little bit. Yeah.
Okay.
And you are not visible properly in the
So
camera. Actually, keep the camera a little far from you so we can see your face. Okay.
now is it okay? Is it okay now?
No.
No,
Hello.
bring your laptop a bit down so that your whole face can be captured. We are really seeing the roof. No, up, take it up,
Okay. That's
better,
okay.
better.
That's okay. Okay. Perfect.
Yeah.
Perfect.
Okay.
Perfect.
Yes. Please carry on. Thank you.
Yeah. So when it comes to role, we had actually distributed the entire project into 9 different roles. The very first role was of Scrum Master. I had taken up the role of Scrum Master. Apart from me, I was also joined by Swarupa Gajali to take up the role of Scrum Master. When it comes to AWS manufacturers, Chioma had taken up the responsibility to work as an AWS infrastructure. And when it comes to CI/CD engineer, Theodora had taken up the responsibility to work as a CI/CD engineer. And when it comes to configuration and discovery, Harini PK had taken up the responsibility of that. When it comes to backend development, Steven had taken up the responsibility for backend development. And when it comes to backend development of visits and the gateway API services, Pamzi had taken up the responsibility of that. For database admin, Rufiat have worked on that, and for observability engineer, I have taken up the responsibility of observability engineer, and QA and demo lead was taken up by Varun Gopal. Yeah, but apart from this, a special thanks from all of us to the director Praveen Mishra sir, to lead co-mentor Praveen Pandey, as well as to co-mentor Tanisha Moran. Next. Yeah. Project overview. It is basically a cloud native veterinary clinic management system built up as an independent services. It is basically built up by combining several independent services, which has its own business logic, which has its own databases, which has its own development life cycle, which also, apart from that, which also has its own CI/CD pipelines. It has been deployed completely on the AWS AWS using the EKS platform. Now for building the AWS infrastructure, we have used Terraform. Apart from that, we also use Docker for containerization. We have used GitHub Actions for CI/CD. And last but not the least, we have used Prometheus, Grafana, as well as the Zipkin services for monitoring and observability services. When it comes to system architecture, first of all, the data is coming from the UI into the system. Then it is going to AWS ELB. Post that, it is going towards API gateway, and from the API gateway, it is moving towards the configuration server, and from the configuration server, it is going at the end to the discovery server. Now, Now, when it comes to technology stack, we have for the cloud and for the infrastructure behind it, we have used AWS CKS we have also built BPSs for it, ALB, EBSs, I am user. All these things have been built up by using Terraform for containers, and for CI/CD we have used Docker, GitHub Actions, and we have used AWS CCR for the backends for the backend tech. We have used Spring Boot 3, we have used Spring Cloud. We also used Eureka and the Spring AI. For the databases, we have used MySQL. For observability and monitoring purposes, we have used Prometheus, Grafana, and Zipkin distributed testing. And for the orchestration, last but not the least, we have used Kubernetes. Next. Yeah, the very first role which was taken by me was a Scrum Master, where I followed up where I actually followed up with each and every member of our team in order to get to know their daily progress. I also interacted with them in order to know what kind of problems they are facing, whether they are stuck anywhere, if they are stuck anywhere, where they are stuck, and what can be done in order to basically solve those problems in order to just to move it. And apart from this, I also monitored all the PRs which were raised across all the branches in order to overcome the conflicts. Now, when it comes to workload management, the very first was nothing but task assignment. We had actually distributed the entire workload, in all our teammates from P2 to P9 based on their role. We used to take the daily follow-ups. Post that, we also used to perform cross perform. We also used to have daily communications. We merged PRs, and then we at the end we deployed, and we were ready for the demo. Yeah. Now the next slide will be presented by Swarupa Vajali. So I will take up back. I'll be on a listening mode, and let Swarupa run the show. Swarupa, you are next.
Yeah. Thank you, Kuntal. Good morning and good afternoon and good evening, time zone. Myself, Swarupa, I worked as a Scrum Master for our Sprint Pet Clinic microservice project. As a Scrum Master, my responsibility was to track the sprint progress and make sure every works smoothly together. First, I helped to set up the GitHub organization and the structure for the project. I coordinate the team, access the permission, and that all team members could collaborate properly. After that, I organize the Scrum workflow using GitHub projects, and we created a Scrum board and with 5 stages. First is to do, in progress, and blocked, and in review and done. This helps us to clear track changes and progress and understand the status of each activity. I created and assigned GitHub issues for the team members based on their roles and responsibilities. For the deployment workflow, we followed a branch strategies. As you show here, the main branch was protected and used only after proper review. And the deployment branch worked as an integration branch where team member pull requests were managed. Each team member worked at their own feature branch and helped to avoid as a conflict and maintain better collaborations. I also coordinate pull request and tracking review and activity to make sure deployment moved smoothly. Overall, my overall my focus on the Spring collaboration is tracking and communication and blocker and management and making sure the teamwork flow stayed organized. That was my contribution as a Scrum Master for this project. Now I will hand over to Chioma, who will explain the AWS infrastructure part. Thank you, everybody.
Good evening. Good evening, good afternoon, good morning.
Your voice is breaking. Your voice is breaking. You can turn off your cam.
Am I audible, please?
You can turn off the video.
Hello?
It will help.
Am I audible, please?
Yeah, it's better now.
Yes. Yes, you're audible.
I'm having a low
You can
network
turn off the video, Chioma.
connection.
Turn off
You
the
can
video.
turn off the video.
Well, can you hear?
Yes, we can hear you, but it's breaking. Turn off the video. You can speak now. Hey.
Okay. Can you hear me now?
Yeah,
Hello, please. Can you please hear me?
Yes.
Am I audible?
Yes, you're audible, Chioma. You can go on.
It's better now. It's better now.
Thank you very much. Good evening, good afternoon, good morning. Whichever time zone you find yourself in. I'm Choma Margaret Nwosu, and I function as AWS infrastructure for the Spring Pet Clinic. And the purpose of this is to deploy the Spring Pet Clinic microservices application on AWS KS using a production-style cloud native architecture, which is to simulate the real enterprise DevOps practices. But I was able to provision AWS infrastructure using Terraform, and I also configured the Amazon EKS Kubernetes clusters. I enabled the persistent database storage EBS for the database, set up external access through AWS application load balancer ingress. I also work on the security aspect, which is the IAM and the security, which help less privilege to help us give access to only those that need access to services. And I was able to create rules that each of my team members assume to function in their work. Some of the rules were developers role, CI/CD role, database role, monitoring role, and Q&A role. At the cost of our work, we thought of reducing costs. And one of the challenges we face is removing NAT gateway. And removing NAT gateway gave us a little challenge. Why? Because our ports not pull container images, and deployment kept failing. So I have to check the worker notes in the private subnet, and I discovered that it could not reach the internet because the NAT gateway was not there. So I have to recreate the NAT gateway using Terraform, and instantly we're able to pull images from our ECR, and deployment was successful. And the lesson learned from here is sometimes cost optimization is good, but it's also important to put in consideration that infrastructure stability is also important. Another challenge we faced was the EBS crash loop. I call it the EBS crash loop mystery because the database got stuck and it kept giving us crash back off, which means the PVC was not binding. And when I look at it, I look at the EBS drive, CSI drive logs, and then I discovered that the correct EBS drive log was not attached. Therefore, I have to reattach it with the correct IAM role so that to the service account. And after that, our PVC was able to bound successfully, and my SQL stateful states came on. And the lesson learned here is that the stateful states depend on the persistent storage. One misconfigured IAM role can block the entire database layer. And last but not the least, though there are many challenges, but I found this one's very interesting. I have the broken trust relationship. And here the developers could not deploy workloads because the kubectl command failed with unauthorized error. When I looked into the AWS auth config map in the kube system namespace, I found out that IAM was mapped to a wrong OIDC provider. The cluster OIDC provider ID didn't match, and that was what caused the issue. And therefore, I have to obtain trust policy to reference the correct OIDC provider for the EKS cluster. And once that was aligned, the role mapping worked and developers were able to regain access. So the lesson I learned here is the OIDC provider ID is a trust anchor. If it is wrong, AWS wouldn't issue credentials, and Kubernetes RBAC will collapse. Not to take too much of our time, there are a lot of challenges and we overcome. Since we are here presenting, we overcame. I want to take a break now so that I can give opportunity to other people to present. Thank you.
Okay, hello. My name is Theodora, the CI/CD engineer for this project. My job was to build the automated pipelines that takes codes from our repository all the way to the running pod on the EKS with zero manual steps. So the pipeline, this is how the pipeline works. When a team member pushes codes to the DevOps branch, to the develop branch, which is our main branch, GitHub Actions automatically kicks off. Okay, at this point, I have to say that not every team member is not allowed to push, of course, to the develop branch because the PR request has to be approved first. That is what I meant. Okay, it checks out the code, sets up Java 17,
which Spring Boot needs to compile the Maven builds or the microservices, downloading dependencies, compiling the Java code, and packaging each service into a Docker image. And these images get tagged and pushed to Amazon ECR. That's the CI part. Then the CD part connects to our EKS cluster, applies all the Kubernetes manifest, and then restarts the deployment so the new image can go live. So this whole process, I think, takes about 3 minutes. So as a CI/CD engineer, I had 2 layers of access, and so to make it clearer, so one of my biggest challenges was getting the pipeline to actually talk to the Amazon EKS. So at some point it kept failing because I had the although I've set up my GitHub secrets on GitHub Actions, I was getting the denied access exception. So I had to work with the infrastructure engineer and discovered that the EKS actually requires 2 separate layers of access, not just the first I was given as a CI/CD engineer, because the infrastructure engineer set up an IAM role so that I could have access. So layer 1 is the IAM policy, which lets you reach the cluster, run commands like, describe cluster. And, she added the CIC, the infrastructure engineer also added inline policy like, describe cluster, list clusters. But after that, the kubectl commands also failed. And that's when we learned about layer 2, which is the AWS auth config map. This lets me inside the cluster so that I can actually run kubectl commands. Like, I mean, the CI/CD pipeline can actually run kubectl commands. Yeah. So another challenge that we came about was the ECR naming challenge. When I first built the pipeline, I tried to push the images to the repos named pet clinic, but the infrastructure engineer had created ECR repos that had a different name, so the push kept failing. So I went through the errors, and I ran AWS EC describe to see the actual names, and then updated my pipeline to match. So the lesson I learned here to always verify what exists before assuming. So there was also the problem of namespace standardization. So different manifest files had different namespaces. So some team members use a different namespace while others use a different namespace. And Kubernetes rejected every mismatched file. So I ran a command, sort of a find and SED command across all the YAML files to standardize everything to one namespace and updated the pipeline variables to match. After that, I also sent a clear documentation to the infrastructure engineer so that we agreed on a namespace that everybody should have to avoid such errors in the future. So I also designed a pipeline to handle, dependencies between team members, so that how do I explain this? Okay, so the pipelines I handle the pipeline so that each manifest file will be handled gracefully. Like, for example, when I set up the pipeline before we had the manifest files, so the CI/CD pipeline was designed to run and wait for each team member to submit, to push their manifest file. So it's going to automatically pick it up when available, then deploy it. So yeah, the end result, I could say that every code that was pushed by all the team members, and it triggered an automatic build and deploy, and no manual steps were needed, and no SSHing into the servers, and no copying files. So, and we pushed to develop, and it went live on Amazon EKS. Also, we also had other challenges which I documented and shared to other team members so that we do not face those challenges again. Thank you. Okay.
Next is Arun.
Hi everyone, I'm Harley. I worked on config server and discovery server for our Spring Pet Clinic microservices. My main responsibility was to establish centralized configuration, management, and a service discovery, which are foundational services before other microservices can work properly. And the first one, the config server, runs on port 88, and its job is simple but critical. The deployed config server reads all microservices configuration files from an external GitHub repo at startup and serves them to every service in the cluster. That means DB URLs, Eureka addresses, log levels, Prometheus state settings, everything comes from here. Every single service in this project is 100% dependent on the server. It must start first. If config server is down, nothing else can boot. I configured health and liveness probes on actual actuator health. So Kubernetes automatically restarts it if it becomes unresponsive. I have set resource limits are at 256 MI to 512 memory and 250 M to 500 M CPU memory. And the next one is the discovery server, which is Eureka. I configured it. It is runs on port 8761. Every microservice register itself here on startup. The API gateway uses the LB// prefix to dynamically route any registered service. So hard-coded IP. So no hard-coded IPs anymore. The interesting part here, how I enforced a startup order at Kubernetes level. I added an init container to the discovery server deployment that holds the config server health endpoint every 5 seconds before the main container starts. I actually confirmed this worked. The init container logged waiting for the config server repeatedly until config server was live. Then I automatically started. No manual timing or sequence needed. The issues I faced while doing my work, I hit 3 real-world issues during the deployment. The first was the AWS load balancer webhook was blocking all cluster IP service creation, even though my services had nothing to do with the load balancer. Then I escalated to P2, which is Chioma, who is AWS infrastructure, who restarted the controller, and both services deployed successfully. Then, after the restarted the controller, the second one is I had an role assumed, which is AWS STS session token, which is expressed after 1 hour. Every time a session expired, I had to rerun STS assumed role and export fresh credentials. It is a real lesson in cloud IAM, how it works as well. And the third issue I was faced was my GitHub push was denied with an 403 error. I requested write access from the Scrum Master, which is Svarupa, and switched it to the authentication and to resolve it, and it fixed. These are the issues I have faced while I'm doing my works and creating my Kubernetes manifest files. And I have finally done all 7 smoke tests, which is all are passed. I have checked the config server health locally, config server serving the connections, Spring profile, Eureka dashboard on local browser, config server health on EKS via port forward, config server serving live config on EKS, Eureka dashboard on EKS via port forward, and the init container dependence improvements all passed. And both the services are running on EKS with 0 restarts. It is all running on its own, and it is all running on its own. And config server and discovery server are the backbone of this entire applications. Without them, no other services can start. And overall, my configuration was building and validating the core configuration and service discovery layer of this project microservices architecture. Thank you.
Hello, Steven.
Stephen available or
Steven available or not? I think.
you can see it in the chat now.
Okay, can I talk? Can I just speak?
Yeah, we can start. We can hear you.
All right.
We can see you also.
Okay. Okay, all right. So my part wasn't too complex. It was just to make sure the customer services were running and also the vet services were running as well. And what I basically had to do was just to make sure the microservices connected independently with their respective databases as well, and also to provision by manifest files to be able to deploy, to be able to push to the main branch via the pull request, and then also to trigger the pipeline. Once I was able to make sure my YAML files were working, the manifest files were working, push them as well to the using a pull request, then to the develop branch, and then the CI/CD pipeline picks it up as well. So upon doing that as well, I discovered that there were issues. I had issues with basically most of the time was the routing issue where Eureka they could not discover, could not register the microservice, which is either both the customer service and also the vet services as well. So we had to consolidate with the group. I had to consolidate with the group as well. So we had to fix the issue, and also I also had issues with the communication with the database as well. I think there was a miscommunication between my team member and I regarding the password for the password and also the key field as well, that was able to add the key identifier for the password as well, and also the username as well. So there were lots of miscommunication as well. But at the end of the day, we were able to come up with the solution and be able to realign our secret as well, and the password went through, and then I had the servers, I had the pod or the container running, the container for the customer service and also for the vet service running up and running. So that was it basically from my end.
Ramsey.
I think Pouncy is not available. She was working actually for the backend developer side. Like she created the gateway part and other services mapped on it. Basically created Docker files and then pulled the details on it. And she also faced some issues while we found it on our testing and all, and we fixed that issues and all. And then she mainly worked on fixing on the backend and front end, like Inters also he had on it. So yeah, that all are basically happened on the backend developer role, and she's not available today to explain too much. Maybe she can explain on the main call like that. Yeah, you can take it to the next slide. And
Robert.
Hi everyone, my name is Rofiat. I work as a database administrator for the Spring Pets Clinic microservice project, Group-2. My responsibility was to deploy and manage my SQL database from the backend services on our AWS EKS Kubernetes cluster. I deployed 3 separate MySQL database using Helm and the Bitnami MySQL charts, 1 database each for each customer service. I have 3 database, 1 for the customer service, the vet service, and the visit service. This follows the database per service architecture pattern used in microservice, where every service has its own isolated database for better scalability, security, and independency. To deploy the database, I create a custom Helm value file for each services and deploy them into a Spring Pet Clinic namespace on EKS. I also create a Kubernetes secret called Pet Clinic -db secrets to secure stored database credential instead of encoding password in configurations file. So after the deployment, all 3 MySQL pods were successfully running, and the Helm releases shows a deployed status as shown on the slide. I also share the Java database connectivity string and secret details with Steven and um Irony, which are the backend service for vet visit and um vet service, so that they could share their connection to the database. So one of the challenges I encountered was during the connection testing. Although the database was successfully deployed and running, I faced some IAM permissions, which it was issued by Chioma. She was able to resolve that. So the reason why I'm facing that permission is because my IAM user did not yet have EKS described cluster permission required for cluster access. This was an access permission issue, not a database deployment issue, after we looked into it with the infrastructure engineer. So there are more challenges experienced within my team with the engineers that work with the backend services, such as naming space and password, which we later reach out to meet and we resolve that amicably. So in summary, I was able to successfully deploy 3 isolated MySQL database on AWS EKS, secure a credential using Kubernetes secrets, configure database connectivity for backend services, ensure all database pods were running successfully, and committed all my Kubernetes configuration files to GitHub. Thank you, everyone.
Yeah. Okay. So yeah. So the so the next role is of observability and monitoring engineer, which was which this particular responsibility was taken up by me, and for this particular responsibility, I had basically used three different tools. And those tools were Prometheus, Grafana, and Zipkin. Now, in all the microservices which we had in our project, Zipkin is basically that kind of a tool, which senses what kind of data is being moved from from one service to another. Now, after sensing, Prometheus comes. Prometheus basically captures that data, which actually moves from one service to another, and in the vice versa manner. Now, in order to show that particular data in the form of dashboard, in the form of KPIs, and also in the form of various kind of visualizations, there comes the role of Graph. Now, in order to show that Grafana dashboard, there is one port, 3000. It is basically live. Now, Prometheus, you will get all kind of Prometheus metrics live on the port 9090. Similarly, now, what kind of issues I faced? So the very first issue which I faced was that of namespace mismatch. Uh, which were there, in almost most of the services and the next issue which I faced was that of a wrong Prometheus service name. Earlier it was as a Prometheus hyphen server, but what the actual name was a Prometheus only. It was changed. It was later on changed by me. And the next issue was that of image pullback off, as the pods couldn't pull the images. So it was also issued. It was also resolved. And the last one was that of Grafana, wrong Grafana label selector. Earlier, I was basically using as name equals to Grafana, but later on it was changed just at the last moment as app equals to Grafana. So this was my role. Thank you. Next is Madhu.
Yeah, thanks, Kundal. I will take it from here. And good day, everyone. I was the QA and ML lead for the whole team. And basically, this role is like we want to test everything rigorously. Like we need to check if anything is break or something. Better I can show you in demo like that. Kundal, I can take the control. Okay.
Yeah.
So you can see my screen, right?
Yes, we can see.
Okay. Basically,
Yes,
we create. You can see the GitHub page, right?
Yes. Yeah.
Oh, okay, fine. So basically, we wrote some test scenarios. Like it is something out of scope of this project, but we write some test scenarios for entirely testing this project in each stages where it is working, where it is breaking something, or like that. So everything we have documented in our repository itself. You can see different scripts like API test, JavaScript, everything like that. I will show the demo for that right now. Before that, I will explain different we have use cases also we have mentioned like that. So basically, I will show you it first, and I will later come to the documentation part. So I have already logged into the nodes, and if I want to do a validation test, I can simply run this script, and it will do an entire validation for the nodes. Like this is the parameter we set for the use case. It will check for all the nodes working or not. And it will give the results like that. Everything we have set a parameter. So each parameter will check all these things. For like now it's showing all the pods are running, all the services are taking. So it will check everything and will show the infrastructure is completely set up. And the next one, we will check the health check for the whole infra and the project we worked on. So it's first checking for the config server. So if it is fail, we need to work on that part and we need to go to that engineer and we'll work with that. Like that, we used to work in the project for last few weeks. If something is failing, we will directly contact with the engineer and we work with them like that. So otherwise, we will inform them if either they can resolve the issue or someone else in the team can work on that part if they are stuck somewhere. So this one also showing the health check is fine. And another one is for the entire API test for the website we built. So right now it is showing that test is again the gateway IP. The gateway IP is showing here, like you can see here. It is going here. This is our front end URL, and it is testing all the stuffs like if something broken on the website or something. We have set up some parameters also. I will show the parameters how we set up in the GitHub portal. I have already documented. And this is another script also we created like for entire full test for the entire infra, then services, then the website we created, it's working or not. Like it will test all things.
Guys, you have only 5 minutes now.
Yeah, sure. We will complete in 5 minutes, not more than it's. This is the last thing, and I will show. I will show the this one chatbot also. That also we work. I will show that also. We will not take more than 5 minutes.
Okay.
And when it completes, I will show you what all the parameters we have all documented here in a page. Yeah, here you can see the test cases. See, this is the parameter I mentioned. For each parameter, it is checking like this. This one we have made in a script like that. So like that, for all things we have made a parameters. So this will check all these things. This is navigating routers and the customer services, web service. Each service it will test. And we have pasted all the results also here. You can see we have tested this multiple times, multiple lines. Initially it was failed, and couple of days before we passed all the steps, and we documented everything here itself, what all things done and all. Then test plans, it will cover all the details, what it is doing and what tools are needed, what kind of testing it is, and what environment we are doing, then how to do that exit criteria and all things we are do. So we will share the repository once the full demo is completed. Then we'll come to the chat demo part. This one we already worked with. Initially, it was not working. So we added a key with the help of open chat. So right now it is working. You can see this. Hello, and I want to add add a new phone owner. You can see my screen, right?
Yeah.
Yeah.
Yes, your screen is, you can see your screen.
Yeah, okay. So I need to give a name. So now if we refresh, we can see here. See here, we can see the role. If you want to add, we can add, but right now that API is not working. If you need to add, it was not working earlier. I'm not sure it will work now. Just getting some API. Yeah, it's also working now.
That's all
I
right.
fixed the issue. So yeah, these all are the basic things I believe for the demo part. Something we added like one is chatbot and the another one is an extra like bonus for the project. Something like added thing to the what I will say. It's a contribution from our project to the community. Something extra we added to the project, I can say. Yeah, that's all from our side, and thanks, Praveen sir, Praveen Pandey sir, everyone for giving us an opportunity. Hope you like our demo and the whole project presentation. Thank you.
Yes, thank you so much. It was a wonderful session from your side. Just I wanted to add something like few people are too fast, few people are too slow. I mean, so you have to adjust these things, okay?
Yeah, good.
For example, Kuntal was too fast and Swarupa was too slow. It seems like she's reading something in front of her. So this kind of thing not work, right?
Yeah, we will
And yeah, apart from this, all you have explained very well. And just take care of time because there will be time limit, right? So you have to explain what you think that is important to explain. I mean, if there is a PPT, we have put 10 lines, 20 lines. So we don't need to explain all these things. Okay. You have to pick important things, what you have to say, what you have to explain within the time limits. So just take care of all these things. We have already recorded video, so you can go through that and see what you can improve and what other team can have done. Okay. Today we have 3 demo sessions. So in one video, there are all 3 groups recorded video. Okay, so you can see there. I have already shared the link in in WhatsApp group. Okay, so you just go and see what you can improve further, right?
Yeah.
Okay, guys, thank you so much.
Yeah, thank you.
Overall, it's what very good session.
Thank you. Thank you.
Thank you. Thank you very much.
Thank you, everyone. Have a good day.
Thank
Bye.
you.
Okay, thank you all. Bye
Thank
bye.
you, sir.
Bye-bye.
Thank you. Bye.
Bye.
Thank you.